Hey, welcome back to my channel. So I'm doing another Thoughts with Amy, and this one is more space related, as you can see. What got me interested in this topic that I'm going to pick on today for space is about a month ago, about February, what was it, like February 12th. So exactly like, well, no, not a month ago because it's April. Well, February 12th, the Trump administration vocally put out that we're going to defund the International Space Station by the year 2025. That caught my eye, and I read a little bit about it back in February, but I never got to read the whole thing. Like, you know how Facebook is, you're constant, like, what do you call it? Like, your attention's like constantly. So like what got me back into it about 2 months later in April is that one of my friends, he posted onto his or Instagram story that he actually saw he actually captured the International Space Station on Earth going by. Like, I was like, when I saw it, I was like, how come I never thought in my mind that we could be able to see from Earth the International Space Station as clearly as some satellite? It boggled my mind how I knew it was like low orbiting Earth thing. I knew it was I knew it was close to the Earth's orbit, but I didn't know it was so close that we could see it with our naked eye. And I didn't know that it was that bright. That actually it actually says I actually did like an hour. I'm such a nerd. On a Saturday, I went, it's 2:26. I started my research at like 1, reading up on the International Space Station, and there's a lot of stuff that I had no idea about. Something that's so far from our planet, but so close and helpful to us here on Earth. But I just found out that, yeah, we can see it with our naked eye. And it's not only that we can see it, it's the third brightest object in the sky at night. Thing is, guys, that, I like read all these facts down. I have to figure out where everything is. Thing is, guys, that, where is it? I put a rectangle around it. Oh, right here. Thing is, guys, you have to keep your eyes open and know exactly when to look for it because it zooms by super fast. I wasn't even thinking, before I talked to my friend, I wasn't even thinking about how fast it was going. Like, how fast would the International Space Station be orbiting? I never thought about that. So if you guys never thought about that, it's actually going, I wrote everything in random places. It's actually going over 17,000, if you're an American, you'll understand miles. 17,000 miles an hour, over 17,000 miles an hour. And it's actually not just going by, it's actually falling as it's descending a little bit closer to Earth as it's going this way. As it's orbiting around at 17,000 miles an hour, it's actually falling a little bit closer, but it's going so fast that it's kind of like the physics of it. You have to be like kind of a rocket scientist, but once you understand the math of it, it's just crazy because guess what? It's going so fast that it orbits Earth every 90 minutes, okay? Every 90 minutes. So what is that, an hour and a half? That's like if you put it in TV terms, an hour of I don't know, Breaking Bad and half an hour of I Love Lucy. Like, the whole Earth. It orbits the whole Earth in 90 minutes and it goes around the earth 16 times in 24 hours. In one day, 16 times. So, going around 16 times, it creates it produces a lot of images of our earth. Like, it sees sunrises, it sees sunsets, it sees multiple things in 90 minutes, and it captures everything. There's a ton of benefits that come from the International Space Station. I'm kind of like this, I'm trying to keep this all in order. I don't know how I'm going to do this yet. Hopefully I can stay in a reasonable order that you guys can follow me with all these facts about the ISS, International Space Station. I might call it the ISS because it's a lot easier to say than that full, the International Space Station. Over and over and over and over again. So, there's a lot of benefits for it going around so much times and seeing what's going on in different spots of the earth, because one of the benefits that of it doing that is that we can see and monitor national disasters in different parts of the earth and focus in on what was happening at the times of those disasters, like fires and tornadoes and just earthquakes, just different things. And so you see images from space, like it can monitor a more clear form of it, so you can see what's going on at that time. What else do I want to say about it? Why was it built? How about this? Let's start from the beginning, okay? It was the year 1998, November 20th to be precise, that we sent our first American-funded but Russian-built, it was called the Zarya module. It was launched up into space. So that was the very first part of it. Okay. Now the International Space Station took years and years to build. It wasn't just, we didn't just construct it on Earth and launch the full thing up in the air. We had to launch multiple different parts in pieces and state. Do you know what? Shoot, I should probably turn on my computer and show you the amount of pieces that we sent up to connect all the all the pieces to erect the full station that it is today. It came in multiple pieces. I mean, if we were to send something up that is as big as it is now, like, there is no rocket that is strong enough or powerful enough that could get it up to space. Let's see. So, International Space Station parts. I will hope this, I should have done this beforehand. International Space Station parts, images, maybe. Oh, awesome. Got it. Let's see, which one's better? They're both good. Maybe, hopefully it comes out. Let's see if I can turn you. Alright, so I don't know how much you can see of that. This is weird because I'm holding the camera. Okay, so that's all the parts. There's a lot of solar panels, as you can see. Darn it, I can't, this is hard. There's a lot of solar panels, as you can see. There's solar panels to run it, and all these multiple little, this is hard, multiple little pieces were sent up at different times. Okay, well, hopefully, let me see, is that even upside down? Oh my god, I have no idea, shoot. Hopefully it's right side up. Alright, hopefully you guys kind of get the picture, or you can look it up for yourselves a bit later. So that's when we first sent up our Zarya module. There are 16 countries involved in this project. That's why it's cool. Like, because space isn't really owned. Like, we here on Earth, we're so divided. Like, Border Patrol and, like, it just seems like we're just so divided. But in space, we're all one. We're all working together. No one owns outer space. No one owns it. It's everyone's. There's no ownership. So the International Space Station has a permanency of 6 astronauts always living there. And other astronauts can visit. It's like such as a friendly atmosphere where people go and they do experiments on, or like do experiments in microgravity that they can't do on Earth that benefits life on Earth and space exploration, life on Earth and science, like just learning. It just promotes human beings, like not like, oh, you're this and you're from here and you're from here and you can't come here. We're all just human beings, you know. We're all the same. So it's just, I like that we can all coexist in one place, and it's no ownership really, and it's just we're all working together to find something to better humanity. Like, could that really happen? I was gonna say, could that really happen on Earth? And no, but yeah, it happens in space. Okay, so anyways, the space station has like I said, a permanent crew of 6 astronauts who perform different experiments for life, Earth and space sciences. So there's a ton of different benefits that they do on the space station that they cannot do here on Earth. That also benefits us on Earth, and I'll go to that. But the complete size of the International Space Station right now, in its completed form, is about the size of an American football field. So yeah, can you imagine sending something up the size of a football field in one swoop? No, that is impossible. So we started in 1998. The second one that we added was in 2001. It was the U.S. laboratory Destiny. And in 2008, a Japanese Kibo lab was added. Some of the benefits, why don't we just go to the benefits really quick? Some of the benefits that this space station, the size of a football field that 16 countries helped build and coincide in, some of the things it does is that since it's so low to Earth, low Earth orbit, we can do really cool things with it. Like, we could see, like I was saying, we can see what's happening on Earth. It also supports water purification and water access to water filtration and purification systems. This is because a lot of the same technologies that we learned about to make or let astronauts live in space permanently for like a year journey, sometimes on end, help us on Earth. Like, we have to figure out how are we supposed to get water to astronauts? How are they going to have clean water to drink, you know? How are they going to survive in microgravity? Yes, there is gravity in there's some gravity in space. Yes, it's not just zero gravity. Like, how do you think the Earth and the moon, you know, stick together, kind of, you know, coincide? There is gravity. That's why they call it microgravity. There's less gravity than there is on Earth. So our bodies aren't used to that. And so it is very weird to put somebody. That's what the International Space Station is. You're actually just inhabiting space, and you're living there. It's like a hotel in space. That's what it is. Okay, so so they needed to get water, to purified water to them. So the actual technology that we use to get water into space is actually the technology we started using to get pure drinking water to places of the world where they can't filtrate water. So we've helped deploy systems to different areas of the world, like the developing world countries that don't have access to clean water, by using technology that we use for the astronauts in the International Space Station. So we use that same technology. Like I was saying with the low gravity, doing things in microgravity where we can have a place to experiment. That's what it is. Laboratories too. It's not just a hotel. It's a laboratory in space where they can experiment and figure out how things react in low gravity. Experiments that we can't do on Earth that we can do in space. So what they were doing is a lot of medical experiments with protein crystals. Microgravity allows optimal growth for unique crystals that can be used for medical treatments. Right now they have got a protein crystal that they are going to put in a drug that is already in the works of treating muscular dystrophy. Sorry, muscular dystrophy. I'm saying it a little off, but it's the protein that they found it's called proteolytic desynthetase. Okay, it's hemotrophine. It's a long scientific word. If you want to put it down to what do you call it? A minuscule size, it'd be HPGDS. That's what we found. We found by knowing that these protein crystals multiply and grow in a microgravity scene more than we could, see it on Earth, in somewhere where we can manufacture a growth of it to experiment on it, needs microgravity to actually see like major benefits of it, so that we could that is one of the things that came out of it, is that they grew these protein crystals and they could experiment on enough of them that they found out that this protein crystal can get added to a drug that can help muscular dystrophy. Another benefit is that it's a lot of medical, guys. Anything that can help us medically, I think, is an advantage. They were saying bringing space station ultrasounds to the end of the Earth. Now, you know how if you're an astronaut in space, you're away from millions of people, you're away from everybody. What happens if you break your leg in space? Or I don't know if you would maybe. What if you need medical attention in space? You're away from you're away from a hospital. You're worse than camping out in the middle of nowhere, But there's remote guidance techniques and small ultrasound units that they use to, teleport, surgeons and stuff, and these remote guidance techniques that they can work on themselves, and from an actual surgeon on Earth telling them what to do in each thing. So, like I was saying, camping somewhere, but let's take it one step further to some place where there's in the middle of nowhere, in Africa somewhere, or some sort of country somewhere where don't have any medical attention, or they don't have the right medical stuff to use, they could get information from these ultrasound units, telemedication, and remote guidance techniques that they used for the astronauts in space from surgeons here on Earth, that they can in a different country that doesn't know what to do next in their medical field. They can use it, you know. Hopefully you guys kind of understand what that whole thing was. It can improve eye surgery. There's this thing that they had to do for, you know, testing and experimenting on astronauts in the space station, that they wanted to figure out how the eyes would react in low gravity situations. So they created this eye tracking device for the space station to control overall eye movements affected by microgravity. It tracks the eye position without interfering. It tracks the eye movements, basically. Okay? So now they use this technology that they use to track the eye movements to see how your eyes react to microgravity in the International Space Station with technology here on Earth. And if you want to do laser eye surgery here on Earth, now a surgeon... Sorry. Okay. Sorry for the break. Still getting over being sick. This cough won't go away. So I had to take a cough drop. I seriously had this cough for like 3 weeks now. This is ridiculous. Anyways, going back into the eye surgery, the same technology that they used to track eye position and to see how gravity affects eyes in astronauts in microgravity, they use in eye surgery here on Earth, like LASIK eye surgery. And this allows them to track the eye position without interfering with the surgeon's work, you know, that they're doing. So this is essential in laser eye surgery. And it's actually used in a large population of LASIK eye surgery right now. It's also making, let's see. Oh, okay. I thought this was interesting. The same with surgery, okay? Going on surgery. Things that surgeons' hands can't get to, or it's not, you know. They have a robotic arm that's performing surgeries on certain people, on certain procedures that can't be done with the human hand, that can be done with a robotic arm. Now, the same robotic arm that was used in these surgeries here on Earth, in the medical field, were the same robotic arms. This is interesting. This is really cool. The same robotic arms from the technology of a family of robots that were sent to the International Space Station to they were robotic, like a family of robotic people that were sent to the International Space Station by the Canadian Space Agency, that would be in charge of lifting things, you know, that astronauts could not, like heavy lifting items. So these were robots that were doing heavy lifting with their arms that people could not do on the space station. So this same technology with the robotic arms in space, it was like a family of robots that helped astronauts in space. These robotic arms that they invented were the same that they used down on Earth to do surgery. Okay. Let's see. Breast cancer detection technology also as well. And as I said, it also, since it's low orbiting to the Earth, it orbits the Earth 16 times in 24 hours and one time in 90 minutes. It captures thousands of images each time that it can tell us what's going on in Earth during a national disaster or at any given time. So that's also another really, really beneficial benefit. Let me see. Is that all I put? I know there's a lot more. Like little kids learning about space, or like, you know, young minds who really want to figure out how to do experiments in space but can't do their own experiments. They actually send them to NASA and they can perform it in a smaller scale for them. It's really cool for the kids. It also, you know, it's also good to see the future generation getting excited about space travel and space exploration and experimenting, because a lot of the things that we can't do from Earth in a microgravity experiment in a microgravity atmosphere may help us on Earth, as I was just telling you some of the benefits. Let's see. Why don't we do some weird facts? This is kind of interesting, okay? Some weird facts about the ISS, the International Space Station, okay? It has more livable room than a 6-bedroom house, okay? If you think that you're going to go to an International Space Station and be like this, I bet you that goes on in your mind. You think of the International Space Station and you think cramped. You think that there's astronauts who live there and they're just like, boom, floating in space, not really enjoying life. No, they have a lot of room in there. Like I said, it's the size of a football field. Inside there are 2 bathrooms, okay? 2 bathrooms. A gym. You know what? I think I might want to do another, like, Thoughts with Amy about astronaut living. Like, how do you use the restroom in space? Because, you know, everything's kind of floating around and everything's different. The way you eat, everything. That's interesting to me. It really is. So there's 2 bathrooms, a gym, a 300... Now, can you imagine the window to look out at? Like, if I would not want to go to space just because of the sheer pressure on your body, the amount of... Like, I can't even go on a roller coaster that goes up and you experience anti-gravity. I black out when I get to 4Gs. When I experience a little over 4Gs, I black out. So I don't think my body could withstand that pressure on me. But in space, if I did go to space, I would love to see the scenery around me. Can you imagine seeing Earth? And no, I don't think Earth is flat. Can you imagine seeing Earth, like, from space? Like, it's just be weird, so weird. And the stars and everything. So you get a 360-degree bay window around you in that place. So you see it. Thing is, it has a gym. Let me go back to the gym. It has a gym. You know why it has a gym? The gym is really important because if you're an astronaut living on the International Space Station, you have to work out. You must work out 2 hours a day. 2 hours a day. And some of us don't work out at all. I mean, I have to work out every day or I just go crazy, but 2 hours a day. So it's like you're doing 2 workouts a day. Like if you normally have an hour workout, you would have to do 2 hours a day. So you do 2 workouts a day. And this is to battle with the bone mass loss. That has to do with, like I was saying, my body wouldn't be able to handle all that. The bone loss, the bone mass loss that you experience because of the anti-gravity and all the pressure. Let's see. It's the largest artificial satellite to ever orbit Earth, and I never thought until I saw my friend's story I never thought about that it does orbit Earth. I didn't know how low it was to Earth that we can actually see it. Duh, we can see it. It's the largest satellite out there, and if you look up at the sky long enough, you'll see satellites every night. You just look up at the sky, and if you see a star, and you just focus on that star, and if that star's moving, it's not a shooting star. Shooting stars go fast. If that star's moving slowly, that's a satellite. So I knew we could see satellites, but why wasn't I thinking you could see the largest artificial satellite in the sky? Like, honestly, like when I saw my friend post that, I decided to look up the International Space Station tracker, and it's orbiting, like I said, it orbits 16 times every day, you know, so you're gonna see it sometime, but it orbits where I live tonight at 8:28 p.m. I set an alarm. I got the app. I set an alarm to see it, but it does go by super fast. So if you don't know where to look, northwest, east, south coordinates, or the exact coordinates, 18 degrees northwest, whatever. And I suck at directionals. Like, I am the most directionally challenged person. I don't know where north is. Like, I know, because I've lived here my whole life, that this is the east because the sun rises over here, and this is the west. The sun always sets over that side. So that must be north and that must be south. So I can, if I'm at my house, I'll know where maybe to look. So hopefully I'll be able to see it tonight. I don't know. If not, I have so many other chances to see it. I mean, it orbits every day, so. But it's kind of cool. It's just like a light. So it looks like a star, but it's going by fast. And I would have never thought that you could see the International Space Station with the naked eye at night. It just boggles my mind. I never thought about that. Why? Anyways, so it has 52 computers in there. If you think of an International Space Station and a laboratory, you think of computers. So there's actually 52 of them, and each computer holds 1.5 gigabytes of storage memory. And a normal computer that we have at home holds only 500 gigabytes on their hard drive. The internal pressure inside the International Space Station is 32,333 cubic feet, which is equal to a Boeing. I wrote it so sloppy that I don't understand, and I can't see exactly what Boeing number model it is. That's a lot of, you have to be, the pressure, it has to be pressurized, just like a submarine going down underneath the ocean has to be internally pressurized. And even the cabin inside a plane that's only like 16,000 feet up in the air, that's going 700 miles per hour. The pressure amount that needs to be equalized so we don't squish. But, oh, that's what I wanted to say. Exactly how far up the, I didn't know if I covered how far up the, how close to our orbit, mileage-wise, the International Space Station is compared to Earth. I wrote it down. It's like, I think it's 200 something. Yeah. The orbit height is 254 miles. So that's close. I didn't know it was that close. Yeah, and the max speed is 17,150 miles per hour. So it's 254 miles above us. Okay, so let's go to the Trump administration defunding this project. All right, so as of February 12th, 2018, Trump defunds the space station, or his plans for defunding it went through. Now, luckily, there's something going on in his mind that he is not going to just defund it. And I mean, I'm still, why defund it if we spent, it's only been up there since 1998, right? So what is that? 20 years? A little less, 20 years. Was it 20 years? 20 years. It's a little longer. Like, I think I'm 98. Like, I'm so old. Okay. So we only started funding it how about we only completed it in 2008? Less than 10 years ago. It was completed 10 years ago, okay, we spent to build it billions of dollars to build it. Okay, hold on. Okay, 13 years to complete at a cost of over $100 billion. Okay, something that was just completed 10 years ago. Why would we completely defend something that has been giving us so much benefits that we could like, if it already gave us medical proof that it can help us grow proteins that can help us to cure diseases here, like, we can further grow and learn things. 10 years is just not enough for something $100 billion in the process. And guess what? You know, going to space is expensive, and I don't like spending money on stuff that, like, but there are benefits. The thing is, though, each trip does cost $58 million to go to the space station. So it is something that Trump has to look at, because it is a lot of money going into this. This is round trip on a SpaceX, you know, those new things, on a SpaceX Crew Dragon or a Boeing CST-100 Starliner. So either a Boeing or a SpaceX. It's going a distance of 220 miles, like we just said. Yeah, 58 million. This is round trip, though. So it's not just to go there. It's to go there and come back. They won't tell us. They tried to get the information on just one round. But I guess you would have to know the round trip, because someone's not just going to live there for the rest of their life. So $58 million to get there, to the space station, and $100 billion to complete. It's a lot of money. So, okay. So Trump's going to defund that all. We're not going to be funding the International Space Station at all. By 2025, we are out. All right, but he does say that we're not going to fund the International Space Station anymore, but we are going to look more into lunar landing, like trips to the moon, which we only, it's controversial. Yeah, we did go to the moon in 1969. It's controversial that first lunar landing was not actually real, that since there was a space race with the Russians, that we wanted to beat the Russians so bad that we faked that one that was on the TV, you know, small step for man, one giant leap for mankind thing was faked. But we actually did go to the moon, though, sometime. And then, as I was discussing with somebody before, that no other people have landed on the moon. No other country. Like, there's machines and stuff on there, but nobody's, like, really gone on the moon since. So the moon has been, like, not in existence for exploring with people for, what, 50 years? Like, so he wants to do moon. And I'm like, if you know me, I am really into the moon. Like, I want to know all about the moon. It's the most prettiest thing to me. It's a whole other topic on its own. It's so significant. It never changes. It's always there. I don't know. It's like a spiritual thing too. It's just really, like, I don't know. The moon has always had a special place in my heart. I guess I'm just weird like that. I feel like such a nerd sometimes. So he is going to defund the International Space Station for moon exploration. Now, he says that they're not going to totally walk away cold turkey from the International Space Station. That, of course, Donald Trump would put real estate. He's going to make it more commercial and somehow privatize the sector into like a piece of real estate. And they promise us, hopefully this promise is true, that we will still be able to get to the International Space Station when we want to. So they still have human access and present in the low orbit, in this low orbit laboratory that we worked so hard to build, spent billions of dollars to finally get up, and we just started getting, like I said, all the benefits. We just started seeing these benefits, and it's only been done for 10 years. Like, why are we just going to spend billions of dollars on it, 20 something millions of dollars to get to there, and then it's like a waste of money, and then we're just going to go spend money on something else, like the moon? Like, yeah, I'm all for the moon, but defunding the International Space Station, I'm not the only one that feels like this. There is people in the Senate, like Bill Nelson. He's a member of the Senate, and he oversees NASA. He says this is really, we're going to have a fight on our hands, because turning off the lights and walking away from our sole output in space at a time when we're pushing frontiers of exploration, and just doesn't make any sense. Where we're just gonna, like, say, turn off the lights, see ya. We're not gonna make any more. That's our laboratory in space, you know? That's where we work. That's where most of our exploration has been going to. Like, most of our rockets that go up into space are going to the International Space Station. That's what it is. That's what we've been spending our money on space, you know, for. And so we're just going to say bye-bye to that. And then Ted Cruz, a chairman of the Senate and a space subcommittee for NASA, he says that he hopes that the reports of ending funding for the International Space Station was as real as Bigfoot. Like, it makes no sense. He said he blames the numbskulls at the Office of Management and Budget for this and how it got to this point. Canceling a program after billions of dollars are put into it is unused. It makes no sense, and it's still usable in the life ahead. Like, we've just figured out what we can do in there, and there's so much more that we can do. And I think that we should probably, yes, there's a lot of money going into it, but it's already built, okay? It's already built. So why not use what we already built and maybe at least get 10, 20 more years into it? After 10, 20 years, we've only been on this for 10 years and we've already gotten this far. If we can see what we can do in another 10, 20 years, if we don't have substantial more, you know, constant growth, then we should defund it. But defunding something after only 10 years is just something that costs billions of dollars. Is just, like, that caught my eye in February. I was like, what's going on? So yeah, I think that's about it. Hopefully, I mean, that is kind of getting into a long video. Hopefully it kind of interests you guys. Space has always interested me, so there's might be more space videos, more science related videos, or maybe just random thoughts. I don't know, but this was fun. So yeah, I wonder if I'm going to be able to see the International Space Station tonight, but if not, there's always other times. So hope you guys have a good day, and see you next time. Bye.